Good morning, iPad Initiative students from OHS. This will be section 2.4 over biconditional statements and good definitions. At this point, we should be doing our half a page of notes on the edge of creations and writing our summary at the end of that. And we should be emailing that to Mr. Lane at lanek@usd290.org. So hopefully that is up and running and working fine by this point. Today's objective is we're going to be writing and analyzing biconditionals. So understanding good definitions can help when explaining anything new to a new person. Good definitions can be written forward and backwards. And the number 5, I don't know, we might start answering that in our notes that we turn in. But not for today. Alright, 2.4, biconditional statements. A statement whose conditional statement and converse are both true can be written as one phrase that uses if and only if. So to be biconditional, both the conditional statement and its converse must be true, and then we can write it as an if and only if statement. I think we'll have some examples here on the next page. But first, let's go ahead and talk about the word bi, meaning two, thus implying two conditionals are true, which would mean that the conditional statement and its converse are true. The symbols, remember we've been talking about symbols all chapter here. Well, P implies Q, but Q also implies P is when we have the arrows on both ends of our arrow notation. P would imply Q and Q would imply P. That's the conditional statement and its converse. If this is all true, then we can write the if and only if statement. Let's see, the examples here says, write the conditional statement and its converse within each biconditional. An angle is obtuse if and only if its measure is greater than 90 degrees and less than 180 degrees. So notice that we're given a biconditional because it's in the if and only if form. So the first thing that we want to do is we want to write the conditional statement. So notice we've got that for kind of P, and this big long thing here would kind of be our Q. So there's our P and there's our Q. So to write the conditional statement, we're going to say an angle is obtuse, or if an angle is obtuse, sorry, then its measure is greater than 90 degrees and less than 180 degrees. Now remember, the converse just switches the hypothesis with the conclusion. So to write it backwards, we need to make the conclusion the hypothesis and the hypothesis the conclusion. So again, we're going to start it off with if, that's a conditional statement. We're going to put an angle's measure. Notice that when I'm writing the converse here, before we had the word its, we're going to go ahead and change it to what it represents, which would be an angle. So if an angle's measure is greater than 90 degrees and less then 180 degrees, comma, then it is obtuse. Alright, notice that both of the conditional and the converse are true. That's why we can write it as a biconditional. I think we've got one more here to do. It says a solution is neutral if and only if its pH is 7. Alright, so we need to write first, so that would be to the converse. The conditional statement is if a solution is neutral, so now this is going to be my P, and my Q is its pH is 7. So if a solution is neutral, then its pH is 7. That would be my conditional. So now I need to flip-flop Q and P for the converse. So I'm going to put if, I'm going to go with a solution, or a solution's pH is 7, comma, then I'm just going to put it is neutral. So notice I've got P implies Q, and here we've got Q implies P, and if both of these are true, then I could write the biconditional. Alright, let's move on. Regular class would be doing those this time. iPad class will have theirs at the end of the unit here. Let's see, our example here is for each conditional, write the converse and the biconditional. So our first one here says if 5x minus 8 equals 37, then x equals 9. Well, notice if we solve for x here, or if we just plugged in the 9, that would be 45 minus 8 would be 37. So the only way that would make this true would be the 9. So we're going to go ahead and write the converse. We're going to put if x equals 9, then 5x minus 8 equals 37. Notice we just flipped the P and the Q around. Well, that would be true. So we can write this as an if and only if, which is called a biconditional statement. So to write the biconditional statement, we're going to put 5x minus 8 equals 37 if and only if x equals 9. And that would be our biconditional. Alright, so down here we're going to have if two angles have the same measure, then they are congruent. So that would be true. We're going to go ahead and write the converse of that then. So the converse is going to flip our P with our Q. So we're going to put if two angles are congruent, and I'm just going to use a symbol to cut down on some writing, then they have the same measure. Now that would be true, so we can go ahead and write the biconditional for this. So to write the if and only if statement, we're going to go back to the original and say two angles have the same measure if and only if they are congruent. And that's biconditionals. A regular geometry class would be doing these problems at this time. We're going to go ahead and move on. Alright, determine if each biconditional is true. If false, give a counterexample. Remember, we only need one counterexample, which is a specific case that proves this to be false. So it says a rectangle has side lengths of 12 centimeters and 25 centimeters if and only if its area is 300 square centimeters. So I believe that the original conditional statement would be true, which is if a rectangle has side lengths of 12 centimeters and 25 centimeters, then its area is 300 centimeters squared. Well, that's true. Remember, if we multiply 12 times 25, we're going to get 300, which is the area formula for a rectangle. But its converse, if I flip the P and the Q around, would state if a rectangle's area is 300 centimeters squared, then its side lengths is 12 centimeters and 25 centimeters. So if we could find any other rectangles which had an area of 300 centimeters squared, then that would be a counterexample that must have 12 and 25 centimeters for its side lengths. So let's see, would 5 times 60 equal 300? So a possible counterexample would be a rectangle with side lengths of 5 centimeters and 60 centimeters, which would be a counterexample to that. We're going to go ahead and shut down here for part 1 of section 2.4. So Mr. Lane signing off as of right now. Catch you later.